Alright, let's start the review by talking about how do you tell which quadratic is the widest. Well, what helps to start this is, let's write a couple quadratics. So we have y equals, say, 3x squared. And then I have y equals just plain x squared. And let's say y equals 1/2 x squared. Let's say we're looking at those three. Now, what you notice is the a value in front is what tells you about wide and narrow. It's the vertical stretch or shrink. And if you think about it, the larger the a value, the more of a stretch it is. And the more stretch it, the more narrow it gets. So basically, the larger the a value, the narrower it gets. So the smaller it gets, you're doing a vertical shrink. So 1/2 is the smallest of these three coefficient a values. So the 1/2 would be the smallest, so it would be the widest. It's called a vertical shrink. So that's kind of how you basically are looking for the smallest value. Now if these were negative, it does not matter, it's just upside down. So no matter what, you ignore the negative and you look for the smallest a value for widest. If you want the narrowest, you want the largest a value of whatever you're looking for. This next one, describe the transformation of this function. Well, this function, if you're trying to describe the transformation, well, you look at the a value again, just like we did here. So what this a value is telling you, it is telling you the vertical stretch or shrink. So this is because it's less than 1, it is a vertical shrink of 1/5, taking 1/5 of the y value, the value outputs. And you're flipping it. So you would talk about this as being a vertical shrink and a flip. It's flipped upside down. Or you could also call it reflect over the x-axis. Instead of flip, you reflect it over the x-axis. Next problem. On which interval is f of x decreasing the fastest? So on what interval is f of x decreasing? So you can tell they're all decreasing, hopefully. Oh, except for actually increases and then it decreases. So we're decreasing the fastest. So you can kind of ignore the first one because it's growing. Then you look here. So we're thinking which one decreases the fastest? So the largest rate of decreasing. So decreasing means rate of downhill. So we're talking about basically slope. Something I probably should have written on this was which rate is the decreasing the fastest. But anyways, they're looking for the rate, the slope. So we check the slopes one by one of each interval. So to do that, what we do here is you take the y values. So 11 minus 3 is 8. 8 divided by 2 is 4. All right? Which is growing, which doesn't make sense. Okay, so we take this one. You take, 5 minus 11 is negative 6. 4 minus 2 is 2. And if you divide that, you get negative 3. So what you notice is from here to here, you are dropping 3 twice. So go from 2 to 4. You're dropping 3 twice. So that's why it goes from 11, dropping 6 to 5. So your slope is negative 3. And then here, 4 to 6, well, the slope here is 3 minus 5 is negative 2. 6 minus 4 is 2, which is a negative 1. So over this interval, you're dropping by 1 twice. For this interval, you're dropping by 3 twice. And for this interval, from here to here, you are adding 4 twice, because you can tell on the top the intervals add 2 each time. So what we're looking for is the decreasing ones, which are these two, and the fastest would be this. Negative 3 is the fastest decay. So that's kind of how we look at it. The key, again, is taking the slope of each interval. This interval, and this interval, and see which one is the biggest. But in this situation, you want the negative because it says decreasing. This was a positive. Because really, this is the fastest change, but it's in the wrong direction. It's an increase. Little tricky, but hopefully it can make a little bit of sense. All right, this next one. Find the number of solutions for this function. So anytime you have a function like this, usually to find solutions, you're setting it equal to 0. So the first step, I always like to get my x squared positive. So I'm going to add the 16 this way, and you put it in standard form. So it's equal to 0. So again, you always get it equal to 0. Then once it's equal to 0, you could solve it to find out the number of solutions, but why? If you think about the quadratic formula, inside the square root, which is right here, b squared minus 4ac, and if you put, this is a, b, and c, into the formula, what you get here is 0. So if you think going through the quadratic formula, if you do the whole thing, you would have something like where you have a plus or minus nothing. So let me describe this to you. If we did the whole thing, it'd look like this. It'd be negative b, so it'd be negative 8 plus or minus the square root of 0 over 2 times a. So let's look at this. Look at this answer. Do you see how it's just going to be negative 8 plus nothing and minus nothing? So this would be negative 8 over 2, which is negative 4. So the answer to this is negative 4 only. Only one answer. Normally quadratics tend to have 2, sometimes 0, but in this situation, because it's a 0 inside the square root, it's one solution, and it actually would be negative 4. But, so if what's inside the square root was negative, it would be no real or too complex. And if what's inside the square root is positive, it'd be 2 real solutions. So you got to kind of remember all that. It makes it a little difficult, but you do have to remember the whole process. All right, here number 5. To solve this inequality, this is inequality because it's not an equal sign, you still want to get it so that 0 is on the right side, so I minus the 4x over. That gives you 1x. Then you want to factor this. So you notice we factor it right here. And negative 42, because you have to multiply 3 times 42. And you have 1 on the bottom. 7 and negative 6. And you divide by 3. Reduce. All right, when you set each of these factors equal to 0, you get negative 7/3 and 2. A lot of times, if you catch on to, it's always the answers, the solutions are always the opposites of the corners in factoring here. But anyways, these are your 2 solutions. Now, the problem is, if it was equal sign, if this is an equal sign, I'm done. But since it's a less than sign, if you do a little sketch, what you have to realize on this format, let's look at just this format. This is the original, this is a new format, and if you graph this, these are really your zeros. So if we were to graph this, we're wanting to know when the graph zeros, okay, when this graph is below 0. So if those are the zeros, negative 7/3, which is negative 2 1/3, and 2, if those are the zeros of a positive graph, see how x squared is positive? So a positive parabola with these zeros, and I'm looking for where is the graph below 0, below the x-axis. Well, can you tell? Right there, the graph is under the x-axis. So on this interval between the values, the graph is below the x-axis, so my solutions are between these dots. If this is a greater than, it would be out here. See, the graph's above the x-axis, but it's a less than. So how do you say between? This is a notation for between 2 values. So between negative 7/3 and 2. And because it's a less than, not less than or equal to, these are lessons as well. Little tricky. All right, number 6, convert to vertex form and find the vertex. So here is standard form, and I want to convert to vertex form. Vertex form is this, HK, has a HK format. So how do we get to this format? Well, you have to do completing the square. So whenever there's an ugly number in front here, it stinks. What you have to do is you have to pull a GCF out of just the x's. So you see right here, if I pull negative 3 out of both of these, I get x squared. And I'll pull negative 3 out of this, I get negative 12x. And I have this blank. I'm going to add a blank here, so on the outside I have to subtract the blank. Where did this minus 2 come from? I just pushed it out. I pushed this c value over. So where do I get 36 from now? Well, remember the idea you take negative 12 divided by 2 and square it. That's where we got 36. Now, why are we here at 36 times negative 3? Well, that's really 36 times negative 3. So you're adding 36 times negative 3 in the front, so you have subtract 36 times negative 3 on the back. When you multiply these two and the negative, and then you subtract them, so you multiply these two and subtract it, that becomes an add 108, which leaves you with negative 2 and 108 is 106. When you factor this, it's always the squared, that's why it's called completing the square. And when you factor this, you get x minus 6 squared with this negative 3 in the coefficient. So this is a sad negative 3. See, the a value is the same for both. Parabola. And the vertex is 6, 106. It's always, remember, opposite of the x value. And there's your vertex. In order to solve this equation, you have to think of this as the end of completing the square. Because when you do completing the square, this is the end result. Kind of like a vertex form. So to get rid of a squared, you square root. See right here, we square both sides. So when you square root, you get a plus or minus. And then why do we have a 5 out here, a 5i? Because if you look over here, first of all, negatives always bring an I out, and 75 is 25 times 3. The square root of 25 is 5. There we go. That's why we have 5i square root of 3. And again, when you square root, you get plus or minus. Over here, when you square a square root, everything is gone except for what's left inside. Now we're just solving. So add the 3 over, divide by 5, and there's your answer. Kind of looks ugly, kind of looks like the end of complete quadratic formula. But completing the square is a very useful method to solve equations, especially the end of completing the square. So really this isn't completing the square, it's square rooting, which is the end of completing the square. So it depends on how you look at it. Next problem, describe the translation of y equals x squared to this function. So hopefully you can see the a value is negative 5, which we said here is a vertical stretch and a flip, also called a reflection over the x-axis. So it's going to be a narrow upside down graph. And the vertex is 3, 7. Now, it's talking about the translation, so you can't just say that's the vertex. You have to describe what that negative 3 does. Well, that negative 3 is a horizontal shift. Remember, it's always the opposite direction, so what would have been a negative is now a positive direction. So that would be horizontally shifting 3 units to the right, the positive. And this is your k, your up and down shift, so you're pushing the graph vertical shift up 7 units. So remember, this is your horizontal, this is your vertical, and this is your vertical stretch or shrink. So just be careful with that. All right, let's solve this one. Now normally when you solve anything with an x squared, you want to equal it to 0. But the problem is, look, I've had an x squared but no x's. Whenever you have an x squared and no x's, you want to get the x squared by itself instead of getting it equal to 0. So let's do it. Get the x squared by itself, as you see here. How to get 240 is I added the 40 over. Now how to get the 6 off, you divide it off. That leaves you 40. So when you get x squared equals 40, you square root both sides to get rid of the squared. And when you break down 40, you should know that's 4 times 10, which is, the square root of 4 is 2. So it's 2 square root 10, because when you break down 40, it's 2 square root 10, and you always have plus or minus whenever you square root. A good way to remind yourself is usually squareds have 2 answers. Most of the time. It just depends on some special cases. Next problem is we're simplifying this kind of ugly looking imaginary number. So to do that, we first need to break down the square root of negative 18. So the square root of negative 18 is negative 1 times 18. So this is I, and 18 breaks down to 9 times 2, which the square root of 9 is 3. So you should see here I got 3i square root 2. So there's 2 different ideas on how to finish this off. Just depends on how you look at it. I am going to first see this right here. You should see 7i to the 7th times 3i square root 2. When I multiply 3i times I to the 7th, I get 3i to the 8th and leave the square root 2. So we got that so far. Then I to the 8th, what you should understand is I to the 8th is, hopefully you can tell, is 1. So replace that with 1. 3 times 1 is 3. You're done. Now the way I know I to the 8th was 1 is I know I to the 4th is 1, and so is this. You could have also broke this down as I squared, I squared, I squared, I squared, a whole bunch of I squareds. And when you multiply I squared, which is negative 1, over and over, in this pattern, you would know it's positive 1. So it's a lot of ideas of learning how to break down I to the 8th. Just depends on how you can see it or understand it. It all depends. Now another way is this, which I haven't really taught it this year, so let's just not talk about this one. Let's focus on this. So let's not even worry about this way at this point in time. All right, when I want to solve this or simplify this, when I have something squared, what that means is multiply by itself. To multiply something by itself, I use FOIL, but you could also do a box. So if you want to use a box, go ahead and use it. But with FOIL, what you're going to do is you're going to multiply 7 times 7, which is 49, 7 times negative 2i, which is negative 14i, negative 2i times 7 is negative 14i, and negative 2i times negative 2i, which is 4i squared. Then you combine these two, the like terms, those become negative 28i, and this becomes I squared times 4. I squared is negative 1, so negative 1 times 4 is negative 4. All right, and then 49 and negative 4 combined to get 45. So right there is your imaginary complex number, 45 minus 21i. F of x equals this vertex form equation. I want to find f of 1. When I say f of 1, what it's saying is replace the x with 1. So I went and replaced the x with 1. So f of 1, replace the x with 1. And now let's do the math. Order of operations, say to do the parentheses first. So that's negative 2. Then order of operations says after parentheses, do powers. So negative 2 squared is 4. Then you do multiply and divide. So we're going to multiply these two, and negative 1/2 times 4 is negative 2. Last step is add, subtract. These two get negative 10. Done. So just follow the procedure. Whenever, if I said f of 8, you're plugging 8 for x and do the same procedure. Just follow order of operations. Parentheses, exponents, multiply, divide, add, subtract. To find the roots, we're basically saying solve. Find the zeros. So in order to do that, I always like to get the x squareds positive. So since this is a negative 4x squared, I'm going to move this way. So I added 4x squared over, so I got this equal to 0. Again, to solve any quadratic, you get it equal to 0, except when you're using the square root method. You want to get the x squared by itself, but this has an x squared and an x, so you can't use the square root method. Now, you plugged in a, b, and c, once it's in this format, into the quadratic formula. Be careful with the square root. This all simplifies down to 137, which doesn't break down, and you're done. It's a pretty simple, quick thing. The only annoying thing is this square root can sometimes have to simplify and it gets ugly. I always try, if I can, factor, but this one didn't seem to be very good factoring, and it doesn't factor because it has a square root. Whenever it factors, your square root will be a lot nicer. It'll like break down to something like a square root of 9 or something. That's when you can factor. That's when that square root's perfect. This one's not like that. If the zeros are negative 6 and 8, then write the quadratic function in standard form. So if I know these are my zeros, let's write it in intercept form, where you get the zeros. Remember, it's always the opposite of these, are in the factored form here. So it's positive 6 and negative 8. But I wants it in standard form, so now I have to convert it to this. So I FOILed it out, multiply, multiply, and boom, boom, boom. Then I combine like terms, and boom, there is standard form. Be careful. On the test, I believe there's choices where you can choose these, and you don't want to choose this format because that's intercept form. You got to go to standard form. So read the question carefully. It's even underlined in saying standard form. Just watch out. The next one is if I have f of x and g of x, and I say what's f of x minus g of x, just make sure you put each piece in parentheses because you have to distribute the negative. So just be careful about that. When you distribute the negative, that becomes a negative 5x squared and a negative 10x. And then we combine like terms. So we combine these two guys, and you get negative 17x. This is your x squared, and there's your 3. So make sure you also put it in standard form. Now, could I also say f of x times g of x? Then I would have this times this, which you would use FOIL or the box to finish it off. All right, for this last problem, there's different ways of doing it. But if I have this function, x is seconds, and f of x is the height of the ball, and with the maximum height and how long was it in the air. So the maximum height is the vertex, all right? And how long was in air was the distance between the zeros, okay? So how to get this graph here? Well, one way you could get this graph to think about this is to do changes to intercept form by pulling out a negative 2x, and then I get this, and then I find my two zeros are, say, each equal to 0 and solve it. So that would be 0. So that equal to 0 and solve it. That's 10. So 0 and 10 are my x-intercepts. So you can see how long was in the air. It would be 10 seconds. Now how do you find out how high it went? Well, you got to find the middle of 0 and 10, which is 5, and that's where your vertex would be. So you put 5 into the function. So you put 5 into the function, and when you calculate it, remember square first, and then you get down to 50, so it went 50 feet high. Because when you plug in the vertex, the output is how high. It's the maximum. Just remember when you hear max or min, you're talking vertex. Sometimes it's the y value, like it was here. It's how high it is. Now there is another way I want to show you real fast. I think it could be a little bit easier. If you remember back to x equals negative b over 2a, that's how you find the axis of symmetry. Well, if you look at this, isn't this your b and your a, and isn't c 0, which you don't even need? Let's just do negative b over 2a. So, let's see. We have the opposite of b, which is 20, over 2 times a, which is negative 2. And what do you notice we get here? We get negative 20 over negative 4, which is 5. Now, what's interesting about that is this 5, isn't that the axis of symmetry? Which, isn't that the 5 we got this way? So if I go put it back into it and find the value 50 the same way. So, alright, so let's think about this. Could I also find my axis of symmetry to find the middle of this graph? Plug it in to find the height. So that is another way using negative b over 2a, instead of converting it to intercept form. Now the question would be, if I know my axis of symmetry is at 5, how do I know it's an error for 10 seconds? Well, if you know anything about axis of symmetry, it's where the vertex is. And the vertex is always halfway through the flight of the ball. So if you think about that, well, 5 here, okay, if that's in the middle of it, you could kind of think through, possibly. It's not perfect, okay. If that's the middle of it, all right, you could plug in some value. You could also find your y-intercept. Your y-intercept is 0. So you should say, oh, my y-intercept is 0. So you know that because my y-intercept. And if that's 5, well, that's 5 across, so I can mirror it back this way. That's tricky. That is really tricky to realize. Your y-intercept is 0. This is the middle. So if that's 5, I know this way 5 is the other hit. And that's how you get the 10. That is trickier. So that can be a little hard to do if it's asking for how long it's in the air. But if it's just asking for the vertex only, then this can be a useful way as well, but it's your call.